Today we're going to look at graphing two types of root functions, square roots and cube roots, the two most basic root functions. This is what the graph of y equals the square root of x looks like. What does it kind of remind you of? What would the problem be? It failed the vertical line test, so what about it? It's not a function. Okay, so if we're graphing square root functions, it'd be a problem to have the whole parabola. So a graph of a square root is just going to be half of a parabola turned on its side. Yesterday we talked about inverses and said that an inverse kind of reflects over this diagonal line, and a square root is an inverse of a square. And then we already learned earlier this year that an x squared graph makes a parabola. So the square root graph makes its inverse, which flips it over that line and turns it on its side, but we only get half of it so that we have a function. So for all of our problems today, we're going to have half of a sideways parabola. To graph, we're going to take care of some shifting first. So we're going to move sideways for what's with the x, and we're going to move vertically for what is after the square root. And then we're going to use an xy chart. So in our first example, we're going to take care of this -2 first. We've talked about shifting functions earlier this year. What happens when we shift for an x? We do. So we're going to go backwards of what it says. So instead of going over to -2, we're going to go over to +2 on the x-axis. So a sideways shift, something that's with the x, goes like the x, sideways, horizontally, but it does the opposite of what the sign says it does. So we're going to shift it over to +2. What's with the y does what it says it does, so that's going to go up 1. So we're going to begin by going 2 to the right and up 1, and that's going to be the end point of that sideways half parabola. Okay, so these are going to have an endpoint for us. They're only going to go on forever in one direction. So the first thing we do is plot that endpoint. Then we're going to make an xy chart based on the parts of the equation we haven't used yet, which would be -3 square root of x. We've already taken care of that -2 and the +1, so we don't need to worry about them anymore. In our xy chart, we want to pick numbers that we can easily take a square root of, because that's an equation. So for every one of our chart, we're going to do 1, 4, and 9 for the x's when we're doing a square root, because those are numbers that will give us nice answers.
How would that give you nice answers?
When you plug it into a square root of 1 is 1, a square root of 4 is 2, a square root of 9 is 3.
Oh, okay.
So we're picking numbers that it's going to turn out to be a nice number instead of a decimal. So when I plug into -3 square root of x, if I plug in a 1, I get -3. If I plug in a 4, the square root would give 2 times -3 is -6. If I plug in a 9, square root is 3 times -3 is -9. Then we're going to plot these values from the endpoint, pretending like the endpoint is the origin. So we are not going to plot the true point at 1, -3. We're going to pretend like that endpoint is the origin and plot from there. So from that endpoint, I'm going to go over 1 and down 3 and plot a point. And from the endpoint, I'm going to go over 4 and down 6 and plot a point there. I don't have enough room to do that last one, and that's fine. As long as you can get 3 points on your graph, that's good. If you can get more, great, but if all you can get is 3, you're still all right. And we're going to connect these dots. Only putting on one side because that other end is an endpoint. It doesn't go on forever there. So in this one, we got the lower half of a sideways parabola. Then we need to consider the domain and range. Domain is the x values of our graph. So we're going to say x for domain. Where does it begin according to the x-axis? So what is the smallest x value on our line? X is 2. And does it get bigger or smaller from there? Bigger. So we're going to go x is greater than 2. So that x value, the endpoint is 2, and from there it gets bigger as the function goes over to the right. Range talks about y. What's the y value of the endpoint? 1. And does it get bigger or smaller from there? Smaller, so we're going to say y is less than 1. So our domain and range come from that endpoint. Domain is the x value, range is the y value. Greater or less depending on the direction the function is pointing.
And it's always going to be less than or equal to or greater than or equal to.
It'll always be less than or equal to or greater than or equal to. Yep. Decide which one it is based on the direction it's pointing. Up or down, left or right. All right. Let's do another one together to practice. First thing I do is take care of the shifting. What does the plus 4 do?
It goes to the left.
Left 4. What's the minus 1 do?
No, wait, no, minus. Oh, down 1.
Down 1. So the x goes backwards, but the y does what it says it does. So we go left 4 and down 1, and that makes our endpoint. Then when we make our equation, we just use the stuff we haven't used yet. So y equals 1/3 the square root of x. In our chart, for x we want 1, 4, and 9. Then we can nicely take a square root of. When I plug in 1, the square root of 1 times 1/3 is 1/3. Square root of 4 is 2 times 1/3 is 2/3. Square root of 9 is 3 times 1/3 is 3/3 or 1. Then we plot these not from the true origin, but from our endpoint. So over 1, up just 1/3. Over 4, up 2/3. And over 9, up 1. Connect them. Putting an arrow just at the one end because the other end is actually an endpoint.
Will it always go to the right?
It will always go to the right, but it could go up or down. So let's talk about what we might be able to determine by the shape of it just from the equation. So our first one was really tall, and this one's really short. What do you think might determine its height? The number in front of the root. So the first one had a 3 there. 3 is kind of considered to be a pretty big number. It doesn't seem like a big number, but it kind of is. And then 1/3 is a small number, smaller than 1. So if we have a number bigger than 1 in the front, we're going to get something tall. If we have something smaller than 1 in the front, we're going to get something short. The first one faced down, and this one faces up. What do you think is going to determine that? Positive or negative. Positive are going to go upward. If there's a negative in front of it, it's going to go downward. So if you kind of think about that before you graph it, then you can kind of verify that your graph looks like what you think it should look like. If it's supposed to be a negative graph and facing downward and you plot your points and it's facing upward, you know something went wrong. So that can kind of help you verify that it looks right. Domain and range on this one. Domain is x. Where does x start?
-4.
-4. Does it get bigger or smaller?
Bigger.
Bigger. So x has to be greater than or equal to -4. Range. Where does y start? -1. Does it get bigger or smaller? Bigger. So greater than. Questions? Okay. Go ahead and try example 3. Yeah. Shifting, that -3 is going to go 3 to the right, and the +2 is going to go 2 up. So I begin over 3 to the right on my x-axis, up 2 on the y-axis. That's going to be our endpoint. Then we make our chart for y equals negative the square root of x. A negative, we should expect this thing to point downward. And then with a multiplier of 1 in the front, it's kind of what we consider to be our standard height. It's not going to be really tall, it's not going to be really short. It's kind of, Goldilocks, perfect. So for our XY chart, we use the same numbers, 1, 4, 9, because we can take square roots. We get -1, -4, -9. Plot those from the endpoint, not from the real origin. Over 1, down 1. Over 4 and down 2. Even though that falls off the graph, I'm going to plot it. It's a really good idea to have at least 3 points. If you can get all 4, that's awesome, but 3 is really kind of important for the curve that's happening. Otherwise, our graphs start to look a little bit more straight than curvy. The negative in the front makes it go downwards. So the negative multiplier in the front is what gives us negative values in our chart to go downward.
So, it doesn't continue from the last point, like you just go back to the first point.
Always go back to that starting point. Yep. Yep. So when you plot them pretending like that endpoint is the origin.
Okay. So it's over 4 and then down 4?
Over 4 and, oops, that's supposed to be a down 2. I wrote the wrong number in my chart there. Thank you. That should be a 2, and this should be a 3. Thank you. Yes.
So the first step, taking the -3 and 2 to find the first point, do you always take the positive? Like it's -3, why did you do it?
Always do the opposite of what's with the x. So if it's x minus 3, I'm going to go to positive 3. If it was x plus 4, I'd go to -4. Always do the opposite, but the y, you do what it says. The number that's outside does what it says it does. The x does the opposite. For domain and range, where does x start? X starts at 3 and gets bigger from there. What about y? Starts at 2 and gets smaller than